Hello students, welcome to my channel Engineer Ash Ma'am. In this video, I am going to solve numerical based on bolted bracket connection. Design bolted bracket connection. An end reaction 240 kN due to factor load. It means PU is given 240 kN. Column section is ISHB 200. Indian Standard Heavy Weight Beam, depth 200 mm and weight is 392.4 Newton per meter. And load acts an eccentricity of 225 mm. Eccentricity equal to 225 mm given. Wave of column from wave of column. Thickness of racket plate may be taken as 12 mm. Thickness of racket plate equal to 12 mm. And bolt diameter T equal to 20 mm is given. So one column of size 200 mm is given. If it is column, ISHB 200 at the rate 392.4 Newton per meter. And one bracket is connected to this column. If it is bracket, load 240 kilonewton, end reaction of 240 kilonewton due to factor load acts at extreme end here, 240 kilonewton. Next, eccentricity 225 mm from wave of column. It means if it is column, if it is flange of column, and if it is wave of column in 3D, is in 3D view. Okay, if it is flange of column, I section beam, ISHB, Indian Standard Heavyweight Beam. Okay, then we know that this is wave of column. And eccentricity is given from wave of column. That is wave of column. This hidden line indicates wave of column. Indirectly, eccentricity from center of flange is given. Okay, so eccentricity from here E equal to 225 mm is given. Eccentricity E0. Thickness of bracket plate. Thickness of this bracket plate thickness of bracket plate 12 mm is given. We have to find number of volts. We have to design bracket bolted connection. It means number of volts required, strength of bolt, etc. Okay, so let's get start. This is given data. First, diameter of hole D naught. The diameter of hole is depends upon diameter plus clearance. So you can see here in IS code, in IS 800, page number 73, table number 19. Clearance for fastener holes are given. If diameter between 12 mm to 14 mm, then clearance is 1. If it is diameter is between 16 to 22 mm, then we have to consider clearance 2 mm. And in given question, diameter is 20 mm. It means 20 mm lies between 16 and 22 mm. Therefore, we have to add clearance 2 mm. Okay. Let's go back to our question. Yeah. Therefore, clearance will be 2 mm. T plus 2 equal to, we know the diameter is 20 mm given. 20 plus 2 equal to 22 mm. Therefore, D naught, diameter of hole equal to 22 mm. Next, first step, design of bolt. Design of bolts. In design of bolts, grades are not given. Therefore, we can assume grade using M20 like bolts of grade 4.6. 4.6. It means in 4.6, 4 indicate 4 into 100 equal to 400 indicate ultimate strength of bolt. And 0.6, so 400 into 0.6, which is equal to 240 MPa. Here 400 MPa or Newton per mm square indicates yield strength of bolt. Okay. Therefore, ultimate strength of bolt equal to 400 MPa and yield strength of bolt equal to 240 MPa. Next, E minimum, that is minimum end distance equal to 1.5 times D naught. We know that D naught, that is diameter of hole, is 22 mm. Therefore, eccentricity equal to 33 mm. Page number 74. IS 800. Next, P minimum, pitch distance, which is equal to 2.5 times diameter. 2.5 times diameter is 20 mm, which is equal to 50 mm. So pitch should not be less than 50 mm according to IS 800. Therefore, we can adopt higher side. Therefore, P minimum equal to 60 mm. Page number 73. Page number 73, you can see here minimum distance between center to center. Distance between center of fastener shall not be less than 2.5 times the nominal diameter of size. It means pitch should not be less than 2.5 times nominal diameter. It means D. Okay, so it should not be less than 2.5 times diameter pitch. And end and end distance here, clause number 10.2.4, end and end distance. Somewhere here is given, that is end distance 1.5 times the hole diameter in case of roll. So, end distance equal to 1.5 times diameter of hole diameter, that is D naught. Okay. Therefore, E minimum edge distance 33 mm and minimum pitch equal to, pitch equal to 60, minimum pitch is 50 mm and consider pitch equal to 60 mm. Next, strength of bolt. Strength of bolt. We have to find strength of bolt. First, strength of bolt in shear, and second, bearing strength of bolt and bearing strength of bolt. Design shear strength of bolt denoted by symbol VDSB, page number 75, and bearing strength VDPB, again page number 75. IS 800, page number 75. Okay, next, clause. Let's see clause. IS code, page number 75. Page number 75 here. shear capacity of bolt. Clause 10.3.3. The design strength of bolt VDSB as governed shear strength is given as VDSB equal to VNSB upon gamma MB, where VNSB is nominal shear capacity of bolt. And formula of VNSB is FU upon root 3 NNNB plus NSASB, where FU is ultimate tensile strength of bolt. And here you can see 10.3.4 bearing strength or bearing capacity of bolt. Bearing capacity of bolt. The formula is VDPB, which is equal to nominal bearing strength of bolt upon factor of safety of bolt, that is 2.5 kb DFU. Let's solve one by one. First is strength of bolt in single shear. First is strength of bolt in single shear. VDSB. Strength of bolt in single shear. We know that formula is VNSB equal to FUB upon root 3 ANB NN plus ASB NS, where ANB is net area of bolt. Net area of bolt, and ASB is shank area of bolt. So we know that cross section of bolt is front view of bolt is like this, and threaded part. This one is head, shank, and threaded part, where cross section area is less than shank. Okay, so at this section cross section will be circular, and if it is at this section cross section will be less or zigzag due to threaded part. So area of this section is pi by 4 d square, and area of this section is reduced due to cut part or threaded part, and area will be 0.78 times diameter of circle. Pi by 4, 0.78 times pi by 4 d square. We know that this section is weaker. If plate, bracket and plate is cut or failed in shear at this section, then we have to assume this area. Okay, and if it is cut at this section, then we will consider this area. Okay, but generally what happened, this is more weaker section, therefore we consider ASP and ASP equal to 0. We consider that our bolt will fail in threaded part because threaded part is more weaker than shank. That's why. Okay, next is VDSB. VDSB equal to VNSB upon gamma MB. Therefore, formula becomes, VDSB formula becomes FUB NB NN upon root 3 gamma MB. Where FUB, ultimate strength of bolt, 4 into 400 equal to 400, and area, net area, 0.78 times pi by 4 d square, diameter square, into NN, number of cuts. So you can see here in main diagram. So shear, if it is bolt here, then this will be one plate, plate 1, that is your bracket, and this flange will be a second plate. Flange of column will be second plate, plate 2. Then if you are considering this cross section, then these two plates will act as a lap joint. And this will be your bolt. 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 Here. Okay. Then shear, bolt will fail in shear due to single shear. So cut possible here. Shear failure can possible at only one section, that is nn equal to 1. So bolt can fail like this at this section, at only one section. Therefore nn equal to 1, that is number of cut will be 1. Okay. Let's fact the numerical. Therefore nn equal to 1 because bolt will fail due to single shear, or number of cuts will be 1, single shear between plate, bracket and flange. Okay. Next, upon root 3 into gamma mb. So factor of safety for material bolt is 1.25 according to IS. Therefore, after solving, you will get the design shear strength of bolt equal to 45.75 kilonewton. Okay, this is the first value, PDS. Next, second is bearing strength. Second equal to bearing strength of bolt. Bearing strength of bolt. That is VDPB. You can see here in IS code. Clause number 10.3.4. VDPB equal to VNPB upon gamma MB, where VNPB is 2.5 kb DTFU. Therefore, VDPB equal to VNPB is 2.5 kb DTFU upon gamma MB. Okay, and kb is smaller of E upon 3D naught or P upon 3D naught minus 0.25 or FU upon FUB upon FU and 1. Okay, so let's solve now. So bearing strength of bolt. Bearing strength of bolt formula is VDSB, which is equal to, VD PB. VD equal to 2.5 kb DTFUP upon gamma MB, where kb is depends upon 4 criteria. T is the diameter, nominal diameter. T is depends. T is minimum of two plates. We know that there are two plates. One plate is your bracket plate, and second plate is flange of column. Okay. Again, here in this diagram. So there are total two plates. One plate is this bracket plate, the bracket connection, this bracket. First plate is this bracket and second is this plate. Flange of, thickness of flange. Okay, this is flange. Column flange. So out of these two, whichever is minimum, that plate will fail. Okay, so I have to consider minimum out of these two. One is bracket and second one is thickness of flange of column ISHB 200. So we know that thickness of bracket is 12 mm, which is given in question, equal to 12 mm. Okay, see here. Thickness of bracket plate is 12 mm is given in question itself. But thickness of flange is not given in question. But size or section of column is given. That is ISHB 200 at the rate 392.4 Newton per meter. So we have to see thickness of flange. We can see thickness of flange from steel table. So now we have to refer steel table. Steel table. Steel table now. Where is steel table? Yeah. There. So I have already opened this page, page number 14. So page number 14, ISHB, ISHB, that is Indian Standard Heavyweight Beam, 200 is given. So roll section, this is I section beam, I section beam. Next, ISMB stand for Indian Standard Medium Weight. Okay, so here, Indian Standard Heavyweight. So you can see here, Indian Standard Heavyweight beam here. Okay, so Indian standard, but ISHB 200, there are two ISHB 200 sections are given in steel table. Then we have to see weight. So you can see here, weight in kg is 37.3 and weight in Newton per meter is 369. Here is given, here is 392.4. Wait up. Let me zoom out little bit. You can see here, weight per meter is given in kg and in Newton. It means this column indicates weight in kg and the second column indicate weight in Newton. And what is given in question? Weight in Newton per meter, 392.4 is given. So back to our question, 392.4 here. 392.4 ISHB is given. Okay, that is weight in Newton is given. For that means we have to refer the second ISHB 200. This one. Okay. Which weight is 392.4. So this one. Okay. So we have to refer this one. Next is thickness of flange. Thickness of flange, you can see here width of flange, thickness of flange, thickness of web, etc. given, depth of sections, moment of inertia, etc. All data are given related to their sections. But we need now thickness of flange. Therefore, in this column, thickness of flange column, you can see thickness of flange is 9 mm. So, it means thickness of flange equal to 9 mm. So, thickness of this flange is 9 mm. Okay, thickness of this flange is 9 mm. And thickness of this bracket is 12 mm. 12 mm. Here you can see 9 mm and 12 mm. So, which one is weaker? Obviously 9 mm because material is same. That is steel. Therefore, 9 mm is more weak than 12 mm. Therefore, we have to adopt thickness equal to 9 mm. Okay. So, in bearing, nest plate will bend. So, here back to our question, back to our steps. Therefore, bracket plate thickness is 12 mm is given and with the help of steel table, flange of column you can find that is 9 mm for ISHB 200. Therefore, adopt minimum thickness which is equal to 9 mm. Okay, so T is 9 mm done. Ultimate strength of plate is 410. Gamma MB is 1.25. Diameter is diameter is 20 mm is given. Next is let's deal with this KB. This KB, what is KB? So IS code is there. You find KB. Let's add to the IS code. Here, IS 800. Where is KB? KB is smaller of these four. So formulas are given. Page number on page number. Where is page number? 75. Okay. KB is smaller of E upon CD0. Let's write here. KB depends upon four criteria. 1, 2, 3, and 4. Right, one by one. First one is E upon 3 T 0, where E is in distance 33, 1.5 times diameter of hole, and T into T naught, that is diameter of hole is 22, which is equal to 0.5. Second criteria is P upon TD0 according to IS 800, page number 70. Okay. Second is minus 0.25. P is pitch 60, T into 22 minus 0.25, which is equal to 0.65. And you can calculate in Calci. Third criteria is FUB upon FUP. Ultimate strength of bolt is 400 and ultimate strength of plate is 410, equal to 0.971. And fourth is 1. Okay. Out of this 4, minimum value is 0.5. Therefore, our KB is 0.5. Done? Go to next page. Let's write down one more time formula. VD, VD, TB equal to 2.5 KB D T FUP upon gamma MB. 2.5 KB is zero point 0.5. Nominal diameter of bolt is 20 mm. Minimum thickness is 9. Ultimate strength of plate is 410. And factor of safety of bolt material is 1.25, which is equal to 73.8 kilonewton. VDEB. Okay. Next. Strength of bolt. Strength of bolt equal to minimum of bearing strength, shearing strength, VDSB, and minimum strength, VDEB. We know that bearing strength is 45.27 kilonewton and bearing strength is 73.8 kilonewton. Therefore, strength of bolt, VD, equal to 45.27 kilonewton. It means if load cross 45.27 kilonewton, then our bolt will fail in shear. If a value of VD is 40 kilonewton, then it's safe. If VD equal to 50 kilonewton, then not safe, or bolt will fail in shear. That means minimum strength of bolt is 45.27 kilonewton. That is strength of bolt or bolt value. Bolt value equal to 45.27 kilonewton. Next, let's find number of bolts. Okay, let us provide bolts in two vertical rows. Therefore, number of bolts in one row. Number of bolts in one row. The formula is root of 6m upon Pn dash Vd, where n is number of rows, which is equal to 2. Vd, as we already calculate, strength of bolt is 45.27. Next is movement. Movement equal to force into distance. We know that load is in reaction is 240 kilonewton and eccentricity is given, that is 225. Okay, let's see again in see here. Movement here. Load is 240 kilonewton. Moment is load into distance or 4 into distance. So 240 into distance is eccentricity is 225 from the center. Therefore, E equal to 225. Then moment equal to 240 kilonewton into 225. Okay. I kept this M in kilonewton itself and 225 in mm because the value of VDE it is in kilonewton. Then kilonewton and kilonewton will get cancelled because one M is at a numerator and VD is at denominator. Then kilonewton get cancelled. So no need to no require to change the unit. Let's put all values. 6 as it is. M is 240 into 225 peach. This P is pitch, not load. Okay. So pitch is given 60 as you already calculate with the help of 2.5 into diameter. N is 2, VD is 45.27. Therefore, number of volts equal to 7.72. So round up is 8 because we cannot provide numbers in points. Therefore, number of volts in one row, in one row, number of volts are in one rows are 8. Therefore, number of bolts in two rows will be 8 into 2, 16. Okay. Therefore, provide 16 bolts 16 bolts in on bracket 16 bolts on bracket plate with 8 bolts in each row. Okay, let's draw one more time this connection. Next is check for connection. Check for connection. Before checks, let's draw one more time. I'm drawing in new page. Let's draw new page. This is column. Column. Here is our sky blue color bracket. Bracket. Number of bolts are 8. Therefore, 1, 2, 3, 4, 5, 6, 7, 8. Here, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8, 16. And load 240 kilonewton here. And eccentricity from center is E not equal to 225 mm is given in question itself. Then pitch distance. So you can see here all distance. We can mark here all distance. So end distance 33 mm. End distance 33 mm. Here is 33 mm end distance. And pitch distance center to center distance between two poles parallel to load. 60 mm, 60 mm, 60 mm, 60, 60, 60, 60, 60. Done. And thickness of this plate is 12 mm. Column size is ISHP 200 column. Thickness of flange equal to 9 mm. Okay. Then CG here. At top side 8. At bottom side 8. At left side 8. Bottom side left. So this will be CG. Farthest bolt or critical bolt will be this one. Okay. So this one will be critical bolt. Let's give it name as A. The critical bolt will be A. Critical bolt will be A. A stand for. We know that the strength of bolt equal to 45.27 kilonewton. We know that the number of bolts are 16. Okay, diameter of bolt is 20 mm. Okay, now let's check whether loads or force will be less than 45.27 or greater than 45.27 or equal to 45.27. It means now we have to compare this VD with force. Okay, that is strength of bolt. Strength of bolt compare with force on bolt. So it means strength of bolt is our friend and force on bolt will be your enemy. So let's compare who will win the race. Okay, will win this war. So if VD will be if VD will be more than F, then the connection will be safe. Obviously, if strength is more, then connection will be safe. If VD is less than F, then unsafe, then we have to redesign. So we will redesign it. So now we don't know what value of F, but we know that the value of VD is 45.27. Now let's find the value of F so that we can compare. So check for bolt now. Check for bolt. Check for bolt means now we have to calculate the force. Force. Force F. Force is F is depends upon two criteria. That is, one is direct force, and second one is force due to torque. Okay, let's direct force is F1 and force due to torque is F2. Okay, then we can calculate F. F will be it depends upon formula, that is F1 square plus F2 square plus 2F1 F2 cos theta. It is your mechanics formula. It means this force is depends upon three factors. F1 is F1, second is F2, and third one is theta. Now let's calculate. First is F1. F1. First is F1, that is direct force on critical bolt A. That is direct force. Direct force F1. Okay, direct force F1. We know that load is 240 kilonewton. Okay, load is 240 kilonewton. And number of volts, factor load is 240 kilonewton. That is 240, and number of volts are 16. Therefore, direct force will be 15 kilonewton. It means one direct force will act, one bolt will share 15 kilonewton load. Okay. Or on one bolt, 15 kilonewton force will act. On one bolt, 15 kilonewton load will act. Direct force will act. Therefore, on 16 bolts, 15 into 16 equal to 240 kilonewton force will act. Or indirectly, we can say that one bolt will take 15 kilonewton load, direct force. Okay. So direct force is just based on direct one formula, that is P upon N, 240 upon 16, which is equal to 15 kilonewton. Therefore, F1 equal to 15 kilonewton. As I already write here also. Already wrote here. Next is second one, second force on bolt due to torque. Second is force on bolt due to torque. Okay. So formula, since torque is depends upon eccentricity, etc. The formula is not direct here. Then it depends upon P, that is load, or PU, or factor load. Next is eccentricity, Rn, and summation of R square. Okay. So we know that PU is ultimate load equal to 240. We know that PU equal to 240 is given in question itself. E naught is 225 mm. 240 kilonewton is given. 225 mm is given. Okay. Next, let's find Rn and summation of R square. What is Rn? Rn is farthest distance from CG. I'm not going to draw one more time. We'll see from here itself. So you can see here which color, which color, sky blue color. So if it is center and its farthest point A, then distance from the center to this point or critical point is Rn. Okay, Rn. So you can see here one triangle. Can draw one triangle here. Okay. So distance from this bolt to this bolt is, we know that 60. Then this half distance will be 60 upon 30. Okay. Distance from this bolt to this bolt is 60. Again this one is 60. Again this one is 60. It means this side distance equal to 60 plus 60 plus 60 plus 30 to 10 mm. And gauge distance is 140. Okay. Total 200 is given. So you can subtract this 30, this distance from this side, this distance, and you will get 140, or you can assume in between. Okay. So 140. So it means 140 upon 2 is 70. This side is 70. So I can draw here the same triangle. See? Not like this. Triangle will be like. Okay. This is 70, 210, and Rn. And this is theta. So with the help of this triangle, we can calculate Rn. Okay. Yes. Correct. Pythagoras theorem. So we can apply here Pythagoras theorem. I'm drawing here one more time, same triangle. It is theta. Rn. This side was 210 and here is 70. Therefore, Rn equal to Pythagoras theorem 210 square plus 70 square, which is equal to 221.35 mm. And theta, cos theta, we need cos theta, cos theta. Okay, cos theta is cos theta. Adjacent upon hypotenuse, correct? Adjacent side is 70. Hypotenuse is Rn. Rn is 221.35. Therefore, 221.35. Therefore, cos theta equal to 0.3161. Okay, cos theta equal to 0.3161. So now we have the value of Rn done, and cos theta again done. Now let's find summation of R square. Okay. So we know that there are total 16 bolts. Bolt number 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And here is CG somewhere here. Here is CG, centroid, CG. Okay. Then Rn is, we can divide all bolts in same category. You can see this bolt and this bolts and this bolts and this bolt. If I'm giving number 1, 2, 3, 4. In this, these 4 bolts are at same distance from center. Okay, 1, 2, 3, and 4. Okay. Next, these fours. For example, number 5, 6, 7, 8. These balls are at same distance from center. Correct? Next. Which color? Which colors? Sky blue color. Okay. Next, these 4 balls. 9, 10, 11, 12. Same distance from center. Correct. And last, let's say white color. 1, 2, yeah, white color balls. All are at same distance. So we can consider only one side and we can multiply it by 4, then we will get the all 4 distance. The formula is summation of r square. Here students, if r equal to root of, if you are considering one triangle, for example, if you are considering this triangle, then this distance is 210 and 70 as we already calculated. Okay, 210 and this one is Rn. Okay, if Rn equal to root of 210 square plus 70 square, then this Rn square will be 210 square plus 70 square. Correct? If a square here at left hand side, then square root will be removed from right hand side. Simple logic? Same. Now, summation of R square. It means summation of this all. So if you are considering this green one, first one green, then this total distance from this line center will be 210. Therefore, and there are total 4 green balls. No? 1, 2, 3 and 4. Therefore, 4 into 210 square plus this distance is 70. 70 square. Done. Next, second one, red color. Plus, there are total 4 red colors balls. 1, 2, 3, 4. 4 balls. All are at same distance. Okay, so you can consider this red triangle here. This triangle. Height of this triangle is minus 30, minus 60. Up to this is 210 minus 60 or 30 plus 60 plus 60 is 150. 150 square plus this will be same. This will be same, that is 70 for all triangles. 70 square. Next is plus sky blue color. Again, there are total 4 types of sky blue colors balls. This vertical distance will be 60 plus 30, 90 square. Plus this horizontal will be 70 square. Correct. Next. White color. Plus 4 distance. So you can consider this triangle, small triangle, 30 and 70. So 30 square plus 70 square. Okay. Summation of r square is, after solving this, you will get answer 380.8 into 10 raised to 3. Okay. We know that Rn is distance. The unit of Rn is mm and r square unit will be mm. So distance unit is Rn is mm and distance square is Rn square. Next, resultant force. Resultant force on critical point. Formula is F equal to root of F1 square plus F2 square plus 2F1 F2 cos theta, where F1 is 15 kilonewton direct force plus F2. Okay, F2. Now we have to calculate F2 also. Here F2, all values are known. Let's find first F2. First find F2. I forgot to find F2. So I'm adding here in slide. Let's find here F2. F2 equal to P E naught Rn upon summation of R square. Correct? Where P is 240 kilonewton, distance is 225 into 221.35 is Rn, and summation of R square is 380.8 into 10 raised to 3. Okay, so answer is 31.39 kilonewton, because we know that 240 kilonewton, 225 mm, and mm square. So mm square and mm get cancelled. Answer will be in kilonewton. Okay, F2. Next. So answer is 31.39. 31.39 square plus 2 into F1. F1 is 15 into 31.39 into cos theta is 0.3162, as you already calculated. Therefore, F is 38.83 kilonewton. F is 38. Which is less than strength of bolt, that is 45.27 kilonewton. It means our enemy is less than our strength. It means safe. Strength of bolt is more than force coming on bolt. Hence, it's a safe. Hence, provide no need to redesign. Hence, provide 16 bolts of M20 for bracket connection to carry load. One more step is pending, that is, do like, share, and subscribe my channel. Hit yellow color. ER dash map. Okay? And thank you for watching.